Assalamualaikum warahmatullahi wabarakatuh. Hello everybody, my name is Zahra Maharani with ID is 2023 32047. In here, I want to for the deep learning particle report for the code cell marker skipped for clarity. In code cells first, the process begins by importing the main libraries used in the deep learning particle. Several important libraries are loaded, including TensorFlow as the main framework for building and training the CNN model, NumPy for numerical operation and array manipulation, and Matplotlib and Seaborn for visualizing training results such as accuracy and confusion matrix plots. Additionally, scikit-learn metric is used to calculate evaluation metrics such as the classification report and confusion metrics. Once all libraries are successfully imported, the system displays the TensorFlow version, indicating that all dependencies are ready for use. Next, in code cell 2, several important constants are defined for model training. These include the image size, bit size, number of classes, and the number of epochs. The dataset used is cipher 100, which is loaded using the TV-Keras dataset cipher 100 load data function. This dataset contains 15,000 training images and 10,000 testing images, is sized 32 pixels with 3 color channels. At this stage, the data is checked to ensure it has been correctly downloaded and is ready to be processed in the proper format before entering the training phase. Then in code cell 2.5, the architecture of the modern CNN model to be used in the experiment is selected. The model choice variable serves as a control to choose one of several models, such as ResNet 15, VGG60, MobileNet, or Inception in this particular section. The chosen model is VGG16. The code also sets the best model function and pre-processing function according to the chosen architecture. This setup allows users to experiment with different models easily by changing a single variable instead of rewriting the entire code. In code cell 3, the data preprocessing pipeline is defined before being fed into the CNN model. A function called is used to resize the image to 224 pixels and apply the preprocessing steps required by the chosen model. After that, a data pipeline is built using which efficiently combines image and labels into a structured dataset. The dataset is the batch according to the batch size. Value and prefetching is applied to speed up the training process. Once this step is complete, a message confirms that the data pipeline is ready for use. In code cell 4, the main CNN architecture is built using VGG16 as the base model. The base model is initialized with the parameters to exclude its original classification layer and to use pre-trained weights from the ImageNet dataset. The base layers are frozen to apply the transfer learning concept, allowing the model to resolve previously learned features such as edge, shape, and textures. On top of this base, several new layers are added. A global average polling 2D, a dense layer for nonlinear learning, a dropout layer to reduce overthinking, and a dense layer to perform classification across 100 categories. The next is code cell 5. It's the model compilation process. The model is compiled using the Adam optimizer with a learning rate of 0.1, the sparse categorical cross entropy loss function. After the model is complete, code cell 6 Queries of the training process using the model fit function. The model is trained of the Cipher 100 dataset for 10 epochs. During this process, two main metrics loss and accuracy are recorded for both the training and the validation dataset. The visualization of the training result presents two key graphs, accuracy and loss. The accuracy graph shows consistent improvement in both training and validation dataset, suggesting that the model is learning effectively without several overfitting. Finally, the evaluation and classification result visualization step is performed after codation 6. At this stage, the trained model is tested on the test dataset to generate a classification report and a confusion matrix. Overall, this deep learning particle demonstrates that using the VGG16 architecture with a transfer learning approach produces fairly good results for image classification on the CIFAR 10 dataset. The model shows steady accuracy improvement throughout the training process and does not suffer from significant overfitting. With additional fine-tuning of the final layers, more diverse data augmentation, and optimization of hyperparameters, the model's performance could be further improved in future experiments. Thank you for me. Wassalamualaikum warahmatullahi wabarakatuh.